Hi. I'm trying to be more practical here to give you an idea of how you will actually implement your own meta-analysis. So it's not going to go too deep into statistics or at all, because Tom's going to do that. And I'm really so how to get a recipe how you would do a meta-analysis. But first, mostly, I think to your supervisor you have to sell that you actually want to do that and why that is interesting. And so the first thing would be there are limitations to single study neuroimaging, and one is that there's a lot of experimental flexibility, meaning you can do, for example, working memory studies with a lot of different paradigms and in different ways. That's showing over 100 coordinates of over 100 working memory studies. And on the other side, there's a lot of analytical flexibility, and here Yoshio Karp showed that you could use the same data and use thousands and some more analysis on it and showing some flexibility of results. In that sense. So single studies have some problems, and among others, there are small sample sizes, indirect measures, and many degrees of freedom that they always have. And on the other hand, what we publish in single studies is isolated findings, very few replications, because it's quite expensive to do, and we tend to overgeneralize to do one n-back task and saying we found the network for working memory. And there, the meta-analysis can actually help us to actually get the real general network for working memory, or getting closer, let's say. So the point here would be there, as made before, there are many studies. It began 10 years ago already, 8,000. Now we just heard we have 30,000 around. Here was an old estimate, 25. And the standardized reported results, and we actually can capitalize this N in doing coordinate-based meta-analysis. And this would allow us, but I want to say as well, it's not only coordinate-based meta-analysis. There is now approaching the possibility to do mega-analysis, and in general, meta-analysis allow us to base inference on huge sample sizes, identify effects that are reproducible over studies, integrate variants of probing specific cognition, so different tasks, way of implementing tasks, and compare topics that are really difficult, as we saw here, over different disease types, for example. Now, different meta-analysis would be one image-based meta-analysis where we actually take the raw data, which would be the real meta-analysis if that's possible. And the other thing would be that you overlap of significant effects or the or do third-level analysis, so testing between experiment effects, which is the classical way of doing meta-analysis. But the compilation of original data is quite difficult. As I said, there are databases for this, and if everybody will contribute their single studies, we would have chances to do real meta-analysis. But on the way, coordinate meta-analysis, as we saw, are really effective and can integrate all the studies that we don't have the raw data available. So we can base it on maximum coordinates, which are very sparse representations, so a point estimator of the effects. But we may integrate all the literature that is available in coordinate space. So that's really a thing to do, as we saw before. Now, what I want to point out is here some rules you should apply to do performing meta-analysis, which are some general selection criteria, specific criteria, and at the end descriptive criteria that will first allow to do the analysis in a good way and then to interpret them in a specific way. But I want to say that this is not specific to coordinate-based meta-analysis, but you have, in any meta-analysis you would do, these rules apply. Now, general selection criteria would be that you look at only voxel-wise whole brain analysis in coordinates you use, but as well you gotta not use raw analysis or partial brain, no small volume corrections or partial brain coverage, even if you have original data. So if you want to look at the whole brain, it's difficult to use other than whole brain analysis. If you use coordinates to do this, they have to be in the standard space. But you got to be careful because a lot of publications, I would say even half, don't really explicitly say in which space you're in. So what's good to know is that SBM and FSL use the MNI space in general, and AFNI and Brain Voyager output the results in Talahara space. And one thing is really important, look if the coordinates were transformed. There's a lot of ways, and if then don't do an additional transformation, but transform them back, and then use it in that space to not introduce some more noise. Now, that would be the general selection criteria to actually find studies that you maybe use, but then afterwards it's really important to get the specific selection criteria right, because they are mutually exclusive in a way. You can either look at cognitive functions, what we could call normal mapping, or we look at patient mapping or group comparisons between groups. So that may be patients, but as well age, older and younger subjects, and so on and so forth. But to pinpoint a cognitive function, don't use group comparison in that, because you can't interpret that. Now, more specifically, cognitive functions don't include any intervention studies, so no pharmacology, TMS, and so forth. Healthy subjects. But if you have a patient study, you could use as well only the control effect, so the same effect in controls. And do use them, because use as many studies you can get. No selected groups, which mean as well not high performers or genetic specific subjects, or specific high performer, low performer, and so on and so forth. So that would restrict your generalization, and you're not getting at the cognitive function. This is the general one, what you would like to do. Okay. So what we look at is between condition effects in normal mapping. On the other hand, we look at patient mapping, we would call it, which is in general group comparisons, which of course include comparisons between conditions, but it's what you see there, the coordinates you would use are the group effects. Higher activation, more atrophy, something like this. So between group effects. Now, at last, it's the most important for the reinterpretation. Now, when we have our specific studies, we've got to look closer to really to tweak our interpretations and to see how generalizable is a meta-analysis. It promises to be really generalizable, but it really depends on your descriptive criteria. And that I want to do with the example, and here would be the working memory. And first, so how do I get the studies? I would just what are the studies on? And there are different variances of this descriptive criteria, which is one paradigms used, which may be Sternberg and Back, which are the most popular in working memory, but a lot of others. Then all these paradigms may be applied with different kinds of items or stimuli and different modalities, and that's the descriptive criteria. And at the end, you can add, or it is added, a lot of distractors for working memory or emotional aspects. Can you remember something better in a positive or negative environment, and so forth. These are all parts of the descriptive criteria you have to mark down and be aware of in interpreting your data afterwards. Now we actually do it. Let's say we do a literature search on working memory. This is coordinate meta-analysis based specific, but let's go there. We just type it into a search engine, like for example, working memory, fMRI, healthy subjects. We get 30 studies, and then we can do our meta-analysis. Obviously, it's not that easy. You really have to, the search is already your data gathering. You really have to do this thoroughly and really look at synonyms, like anything you can think of working memory. Not use only fMRI, but functional MRI, neuroimaging, and so on and so forth, because it's really dependent on which journal it is published, for example. Healthy subject control. So look at that and related topics, and use different search engines as well. So there will pop up even more articles. And one thing is very useful: use your favorite review article of a topic, and mark down all these studies that are in there that you like, and then do reference tracing. So each study has other ones, and in the end you arrive at the same ones, but thereby you find a lot of others that you don't find like this. And this is really one of the most important parts to get your data. So if you have the data, organize it. That's very important. Note down any of these descriptive criteria that I was pointing to. And the first thing that when we talk about meta-analysis, we should talk about the difference between study and experiment. The studies will mean all the papers. One paper is one study, but one paper has different conditions, different contrasts, and these different sets of coordinates, and these sets we will call an experiment. And that you could see here on the left, there's studies that contain like 5 experiments, and note this down like this with the subjects, because it's got to be important in actually modeling the activation afterwards. Next thing, like the specific contrast is really important to get the interpretation right, because if you only have a high-level task to baseline, it's all in there. It's the visual stimulation, it's a lot of other things, and working memory is there as well. But on the other hand, if you have a high-level baseline, then it would be really specific to working memory, the activation. And you got to know what it is, the contrast, to actually interpret it in the end. Otherwise, if you put it all together, it's just working memory somehow, and everything related. The task is important because you can actually do comparisons between the tasks if you have enough. And modality, stimulus type, you can play this game as far as there are enough studies for it. So note down everything you can think of, and then if you have enough studies, you can really compare things that in an experimental setting directly you can't do that really. Or it's really difficult to do that, I would say. Now, descriptive criteria, just to reiterate, because it's really important, maybe paradigm type, because it determines what the meta-analysis represents. If we would have like 50 NBAC tasks and like one Sternberg and the rest in there, and you call it working memory, that's not right. It's a meta-analysis on NBAC task, which is interesting itself, but it's something different. It's really driven by I would say one of the main drivers is the paradigm type that you put in a study. And the contrast type on the other as well, because you can get more specific what actually the activation or atrophy or what you want to head at is related to, specific function or a specific effect. And this could be a lot of things. And it really depends on how many studies you can compile to do sub-analysis with it. So it can be really specific to reaction time covariate correlations on working memory, for example. And that could be interesting. Where is it located within the whole network? All right, this will determine the results, and then you have to interpret it from there. And I would really encourage you to do more sub-analysis on the same data to really pinpoint it, as we do on fMRI data or VBM as well, or any kind of data we are analyzing. Now, there's the question: how many experiments do we actually need for a good inference? That's a difficult question. You can't really pinpoint it, but and how to correct for multiple comparisons. But just on ALE, that we did a huge simulation studies, and the impression, or we could show that around 20 experiments you are okay, which doesn't mean that there are studies with less really specific and really similar studies you need less that are well done, or you would need more with really noisy or older studies. So the 20 is not fixed. It's you got to look closer anyhow, right? And using cluster level inference in this, which seems the most stable for ALE, for example, at least. So in the end, it's really the criteria that define what you can interpret and what you put in the studies. And I think that's really important that you refine a study. And it's like in a fMRI study where you think a lot of your paradigm, and where you actually really tweak your paradigm to get what you want to see in the brain. And here you actually really have to look at your primary data, which coordinates on one hand, or if you have original data, make sure that it's similar enough so that you can put them together and have a good general or a good generalization. And not only because of your data, put it together and then say it's something general. All right. Question?
Let's thank Felix.
Well, thanks for really highlighting the fact that it's not just throwing something together, but it's a study that you have to plan at least as carefully as an original study. I think that's a very important point. Other questions, comments, thoughts?
I guess a simple question of if some studies really use the same participants, different experiments, is somehow factored in analysis, really use the same participants.
Yeah, in the ALE algorithm, it's factored in, and it's taken into account that it says that you don't overrate, and even as well the effect that you have more coordinates in one study than another, and if they overlap, it's factored in as well. So it's tried to be modeled as well, to not having some samples that are scanned over and over or have 10 contrasts really drive the whole study. Yes, and that's one thing you really have to look at later, is that you have a lot of different studies and not only a lot of studies that have a lot of contrast in there. So look at the studies and the experiments, the number. And just one thing, if you plan in meta-analysis, look maybe to the ANIMA database, ANIMA, which will be mentioned later, where we have a database where actually the results of meta-analysis are already in. And as well, of course, BrainMap and Neurosynth, where the coordinates are stored, where you can actually have a look on already papers that you can start your own meta-analysis on and then look into literature.
More questions?
For the talk, is it possible to, I mean, you already have a database with these coordinates, but I believe they may be limited. So are we going to be able to track these studies and pull the coordinates into the software?
I think we hear about the BrainMap database later specifically, and I think Andy will be a lot more qualified to answer these questions. Yeah, but in principle, yes, I think yes.
So I guess for things like working memory, which is a construct that potentially is very consensual and not very problematic to select the studies that deal with working memory that you can input for meta-analysis. But if you're talking about things like, for example, processing hierarchy, how do you know which studies you can include in your meta-analysis or not?
Yeah, that's the question I'm trying to raise here, the sensitivity. There's no general answer to this. It's really that conceptual work that you have to do with it and look at what did the experimenter in the specific study had at. And not only trust the words they used there, but actually look, okay, how was that implemented? How did the paradigm look like? So what did they contrast actually in the tasks? So you gotta think of the task, how it worked, and then compare the tasks and not only the word like hierarchical processing. Yes, so you really have to get into the cognitive domain there and to look at it.
So you could not really use automatized methods?
I don't think so, because I mean, as a starting point, yes, but the curation of your data restricts the generalizability. If you don't curate it and don't look at it, you just have some kind of network. And if it's called hierarchical processing or whatever, executive, or it depends. If you have enough studies, that's one argument. Then it should converge to at least partly a meaningful part. But I would really, I mean, if you compile it yourself, really look at it. If you have the numbers are high enough, do this, then do some kind of conceptual cross-validation in saying, okay, does it look like a network that may be reasonable for this kind of processing?